In this video, I will explain you concept electric field. First, let's see the definition. Electric field is an effect in the space due to which a charge experiences a force. So let's say we have two rooms nearby. This is just an example, okay? So in one room, I have kept some charges, positive charge, say for example. Person in this room can't see these charges, okay? So person in this room, so let's say I am here, I have charges with me, I kept it here, and we know that though there are medium in between, these charges will be able to attract any charge if I am keeping here, because these field lines can go through the medium and it can bring, if it is negative charge, it can bring here. So this is the experimental setup. Now a person in this room, he is keeping, let's say, a negative charge, an electron here, but he will see that electron will be moving in this direction, okay, but there are no charges in his room. Now he will keep an electron here, but these electrons will be moved in this direction. Then he has kept an electron here, it is moving in this direction. Then he has kept an electron here, it is moving in this direction. What is the reason here? See, there are no charges in this room, but how will this electron be able to move? The reason is there are forces exerted by the positive charge on the electron. But how? In this room, we don't have charges, but we have the presence of this charge on this room. Okay, so that property is called as electric field. So now positive charges or whatever may be the charge, this will create a field, electric field around it. And whenever we are keeping a charge in that field, then that will be either attracted or repelled by that field. Another example is, see, we have earth. When we are keeping a substance M here, the moment we drop, it will come inward. What is the reason? We have kept the object in the gravitational field of earth. But if we are keeping it in the space, will it come? No, because it is out of gravitational field. So this property is nothing but electric field. But when it is defined for charges, it is electric field. When it is defined for masses, then that is gravitational field. Now electric field is an effect in the space due to which a charge experiences a force. Now there is an effect in this room, and due to that effect, whenever we are keeping a charge here, that experiences a force. So field is explained here. Now how to get the intensity, how to get the value of electric field, that is defined with this definition. Intensity of electric field at a point is measured by a test part, measured by force on a test particle of 1 coulomb placed at that point. So intensity of electric field at a point is measured by force exerted on a test charge particle of 1 coulomb placed at that point. So here in this example, instead of E, I will place 1 coulomb, and we'll see that force exerted on this 1 coulomb. So obviously if this is positive, it will be a repulsive force. Now the force exerted on 1 coulomb, this is test charge, okay, test charge, it's a standard defined test charge. Now force exerted on a test charge of 1 coulomb by this is called as electric field at that point. So it's a point property. With point, the value will change. Now here if I am keeping a 1 coulomb, it will be repelled in this direction. And how to get the value of intensity of electric field at this point? Just find the force exerted by this on 1 coulomb. Okay, now how to get the value? We know that force in between two charges is equal to 1 by 4 pi epsilon 0 Q1 Q2 divided by R square. Now let's say we have Q1 here. Now Q1 is creating an electric field around charge Q1 itself. Now how to find electric field due to Q1 at this point? we will place a test charge of 1 coulomb here and we'll find the value of force exerted on 1 coulomb by Q1. So what will be the force? 1 by 4 pi epsilon 0 Q1, Q2 is 1 coulomb here, divided by R square. So the electric field is equal to 1 by 4 pi epsilon 0 Q1 by R square. See, who provides the electric field here? Q1 is providing an electric field, and that is exerted on 1 coulomb. Now how to get the electric field at this point? As per this equation, 1 by 4 pi epsilon 0 Q1 divided by this distance. So let's say this is P. So point P, this is point Q. So this is R1Q in between 1 and Q. This is R1P in between 1 and P. So this will be the electric field at this point. So at any point, if you want to find the electric field at this point, keep 1 coulomb charge and find the value of force exerted on 1 coulomb by the charges across. It needs not to be charged. Let's say we can create electric field by other way. Without a point charge we can create. So these are point charges, right? Q1 is a point charge here. Now if you are keeping a charged sheet, this will create an electric field. I will anyway explain you the value of electric field created by a charge distribution, simply charge sheet, in the coming lectures. But anyway, a sheet can create an electric field at this point. How to find the value of electric field? Just keep a charge of 1 coulomb here and find the total force exerted on 1 coulomb by this charge sheet. You will be getting electric field at that point. Now electric field is nothing but force on 1 coulomb. Now if I am keeping Q coulomb here, then I will get force on Q coulomb. Now E has been defined as force on 1 coulomb, right? Now I can also get force on Q coulomb with an equation F is equal to QE. How will I get the value? Force on 1 coulomb is E. Now force on Q coulomb will be QE. So it is very simple now. If you know electric field at a point, electric field is nothing but force exerted on 1 coulomb. Now if I am keeping Q coulomb at that point, then the net force will be QE. See? Now this can also be derived in one more way. If you know the equation for electric field is equal to 1 by 4 pi epsilon 0 Q divided by R. So electric field due to a point charge at a distance of R away from point charge is equal to 1 by 4 pi epsilon 0 value of point charge divided by distance in between them, the point and the source charge. Okay, now this is the equation for electric field. Now equation for force, if I am keeping a charge of Q2 here and if this is Q1, then the force in between them is 1 by 4 pi epsilon 0 Q1 Q2 divided by R21, because the force exerted by 1 on 2, right? R21 here. Exerted by 1 on 2, yes. Now this one also electric field, this will be 2-1. So here it's a point, right? So I will mention it as P1 because it's a point property, right? When we are checking the value of electric field, there is no charge. It is defined for 1 coulomb as a standard. There are no charge here. Okay. Now when I am keeping Q to the force is this one. But what is the value of this one? 1 by 4 pi epsilon 0 Q1 divided by R21. That is same thing, right? 1 by 4 pi epsilon 0 Q1 divided by, now 2-1 is nothing but, here previously it was a point, in between point and 1 it's the same distance as compared to 1 and 2. So these two values are same. So I can replace this one with E. So F is equal to E into Q. So F is equal to Q into E. Now we know force is a vector quantity. Q is a scalar quantity. Now LHS is a vector quantity. So RHS also have to be vector quantity. So the value will be E. So the value E will be vector quantity. So this is vector is equal to scalar into vector. F is equal to QE. Okay. This is very important. And one more thing. This is the value of force. Okay. And value of electric field can be written as force in between two charge divided by this thing. So you can have multiple equations for electric field. One is, this equation is for point charge, 1 by 4 pi epsilon 0, the point source charge. So this is the source, right? This is exerting electric field. This is creating electric field around it. So this will be taken as source charge, and this is test charge. So source charge exerts on test charge. So you can have different equations, but this equation can only be applied for a source charge. If you don't know source charge, simply we can consider that electric field at that point is equal to E. We don't know who is creating electric field. Electric field at a point is E. When we are keeping a charge of Q, then the force will be F is equal to QE. I'll repeat it. Let's say we don't know who is creating electric field. For example, we have an electric field in this direction. We don't know who is creating it. There is no source charge. How to find the electric field at this point? It's very easy. We will keep a charge of Q here and find the total value of force. So we will get the total value of force as Q into E. This is the relation, right? So F is equal to Q into E. So we know the total force now. We have calculated. We know which charge we have kept here. Now how to get the value of electric field? E is equal to F divided by Q. So E is a vector quantity. Now what will be the direction of electric field? The direction will be same as that of force. But here, for electric field, the direction is well defined. It's not the way it is defined for force. For electric field, how electric field has been defined? Force on 1 coulomb, right? So if you have a positive source charge, how to get the value of electric field? At this point, electric field is force on 1 coulomb. Okay, so source charge is this one. Direction of electric field will be the direction of force that the source charge exerts on test charge. So this is the direction of force. So this will be direction of E as well. Okay, simply when I am keeping plus 1 coulomb, in which direction it is moving, that is the direction of electric field. Now if I am keeping plus 1 coulomb here, in which direction it is moving, that will be the direction of electric field. When I am keeping 1 coulomb here, in which direction it will move? With respect to this, it will move here. With respect to this, it will move upward. So that is direction of electric field. Now if the source charge is negative source charge. But definition for electric field is the same. Keep a plus 1 coulomb and which direction it is moving, that is the direction of electric field. Here it will move inward. Negative attract positive, right? Plus 1 coulomb, if I am keeping here, it will attract in this way. Plus 1 coulomb, if I am keeping near to negative, that will be moving in this direction. So for a negative source charge, a point charge, electric field will be inward. And for a positive source charge, it will be outward. Simply, so if you have confusion, to remember in this way, keep a positive here. Positive source charge. What will be the direction of electric field? I am keeping plus 1 here. In which direction it will move? Radially outward. Plus 1, radially outward. Plus 1, repulsion, radially outward. Plus 1, repulsion, radially outward. This is the electric field due to a positive source charge. Now electric field due to a negative source charge. Keep a plus 1 here. In which direction it will come? Inward. Plus 1, in which direction it will come? Inward. So these are radially inward. See, with positive it is radially outward, with negative it is radially inward. Okay, this one is very, very important. Be very clear with the concept. Make a note of it. Thank you.